All right, so now we're going to work through various operations with rational expressions, multiplication and division specifically. In this case, we've just got multiplication of a 1/5 times a larger rational expression. So we're going to perform the operation and then rewrite the answer in simplest form with a single fraction, no parentheses. That means at the end, we're not going to leave it in factored form. We're going to go ahead and multiply things out. So here we just get to multiply straight across. Nothing truly exciting here. On the top, you just get a -4. And then on the bottom, we do need to consider this x plus 5 as a binomial expression where I distribute the 5 that I'm multiplying in there. So that's going to be multiplication straight across. It's going to look like 5x plus 25. And this is what we're looking for to be in simplest form. Right, in this second example, I have students often come to me with questions and they're not sure what to do with that 7 because they see the fraction over here, but they don't see the fraction that is the 7. Well, everything can be re-represented as a fraction because there's an invisible 1 that we're dividing by. So you want to make it into a fraction so that you can see the 7 is actually a numerator product and the 1 is the denominator product. So really this question, this whole number 7, times this rational expression is 7 over 1 times this function right there. All right, so we take the 7 and multiply it times the x plus 3, and that distributes in. So it's going to be 7x plus 21. And the denominator is just 1 times 3x, so we just have 3x. And then it says reduce or put it in simplest form or single fraction with no parentheses. This is the answer. A lot of students they get really excited and they're like, well, but Ms. Strugger, you got x's right there. Those can cancel, right? No, they can't. You cannot cancel those because there is a plus sign, and that plus sign does not allow you to divide vertically. It has to be division of products. If there was an extra x on the outside times this thing, then I could reduce this x with that x. But it has to be a product. It can't be a sum here. And same thing with the 21. I know 3 goes into 21. I understand that. But it is not a common factor with the 7. So there would have to be an extra product of 3 out in front for the 3 to reduce vertically. So the biggest caution I have is oversimplification when it's not possible. This is the answer. We need to stop right there at 7x plus 21. So in this problem, we have a fraction times a rational expression, and the 3/8 just gets multiplied straight across to this x over 3x minus 2. So there's going to be 3x on top. You just 3 times the x over. I need to distribute that 8 into the parentheses there. So we get 8 times 3 to get 24x, and then 8 times -2 to get -16. This, we then look for any simplifying that can be done. There's no vertical reducing, just like I spoke about a moment ago. You don't want to reduce those x's. That is not a thing. Do not do that. The 3 and the 24, you can't do any. This is it. You cannot reduce because there's a minus sign right here. Those x's are not in common as a common factor in the top and the bottom, the numerator denominator. And now we look at division of rational expressions, and then we'll simplify. So again, anytime you see division, just think in your brain, it's actually multiplication of the reciprocal. So it's 1/7 times 3x over 3x plus 5. And I often have students right away, they're like, oh, Ms. Tugger, you can cross out those 3 x's. They're the same top and bottom. Well, there's a 5 over here, so the plus 5 means that you cannot do that. They are separated by a plus sign. And so what we're looking for is to go ahead and multiply straight across here. And the numerator is just going to be a 3x. The denominator, you get 7 times 3 to be 21x. And then 7 times 5 to be plus 35. And that's as far as we can take this problem. You cannot reduce the 3x and the 21x. It would just be like if you had 2 over 2 plus 5. That is not 1/5. It is 2 over 7. So you can't reduce these 2's because that would be impossible. Just like we can't do that here. You got to stop right there. All right, then we have these problems where we have a whole number and a division or multiplication of rational functions. And again, students get a little stressed out by seeing the whole number there. not sure what to do with that. Remember, any number is a fraction, just put it over 1. And you have a division of rational expression just results into multiplication of the reciprocal. So it's really negative 2 over 1 times x minus 3 over x minus 5. And then we go ahead and throw parentheses around the x minus 3 because we're going to distribute the 2 into it, multiplying straight across here. And the 1 on the bottom just results in the way x minus 5 stands. And then we take the negative 2 and distribute, watching the negative sign. So negative 2 times x will give me a negative 2x, and negative 2 times negative 3 should give me a positive 6. There is no reducing to perform because we can see right here the factored forms were different binomial factors, so no vertical reducing will happen. So in this final example, we have a negative 4/7 divided by this rational expression. So anytime you see division, just rewrite it to be a product of the reciprocal. So negative 4/7 times x minus 6 over 3x plus 10. And then we need to distribute. That's a 10. So we distribute the top and the bottom this time. So negative 4 distributes in there and get negative 4x plus 24 over 7 times 3 should give me 21x, and then 7 times 10 should give me plus 70. And then the only thing you need to worry about after that is looking for anything that would have reduced. But I can see that back here in the factored form, these didn't have anything in common. 3 and the 10 didn't have anything in common. 4 and 7 couldn't reduce. 4 doesn't have any common. There's no reducing that can be done. And the easiest way to see that would have been back over here in simplest form is what I'm trying to say to you. So this is the simplest form after the result of dividing by the fraction, which means multiplying by the reciprocal. All right, in this final example, we have a division of a complex fraction, just a rational number, negative 1/10. So what you do is you write the top expression, and then as a product of the reciprocal, negative 10 over 1. Now, what I have most students concerned about is they see that negative sign and they say, well, do I put it to the top or does it go to the bottom or what do I do? You just pick one. It doesn't matter. As long as it only shows up once. And then we go ahead and distribute that. I'm going to distribute that negative 10 to the numerator. So that's going to be negative 10x plus 10 over, this denominator is just 2x minus 7. And that's as far as that problem goes. That is I performed the operation, and that's as simplified as that problem will go.